Okay, take two on my second video here. I've asked the kids to be quiet, so that's okay. We'll forgive them. So what we're looking at now is a very similar function to what I had the first time, except that my squareds are already in there. And what that does is it changes the Cartesian equation significantly. So let's again consider the part in front of the vector I. I'm going to make that my x function. I'm going to say x of t equals 2 cos squared t. And then my y of t is going to equal 3 sine squared t. Okay, so I've set up my two functions. Again, they're both in terms of a trig function, so I'm going to use an identity to set up my Cartesian equation. So, almost identical to before, I'm going to divide both sides by 2, except this time, I don't need to square both sides to make it a cos squared. It's already got cos squared, so I don't need to do anything more there. Same with my y, I'm going to divide it by 3. But I don't need to do anything more to make it sine squared. I've already got my sine squared. So now if I use the trig identity sine squared theta plus cos squared theta equals 1, I can simply substitute in y on 3 plus x on 2 has to equal 1. And I've got my relationship set up already, except I'm not used to seeing it looking like this. Now this is actually a linear graph in intercept form, and some of you may have heard about linear graphs being written in intercept form before, but what you would more likely be used to seeing is something that looks like this. So I'm going to multiply everything by 3 first. And that I nearly forgot to multiply the right hand side there by 3, and then I'm going to multiply everything by 2. No, I'm not actually. I'm going to just rearrange that, and I'm going to move the 3x on 2 to the other side of the equal sign, and I very quickly set up my linear equation where I know the y-intercept is at 3. So my y-intercept is at 3, and my x-intercept goes down 3 and across 2 places. So my x-intercept is at 2. So 0, 3 and 2, 0. Draw my linear graph through those 2 points, and I have my function. So this is y equals negative 3x on 2 plus 3, or there's nothing wrong with leaving it written like this because it is a relation. And as I mentioned, if you haven't seen it before, this is called a linear equation in intercept form, where the value that I divide x by is the x-axis intercept, and the value that I divide y by is the y-axis intercept. It only works when it's equal to 1. But if you recognise that, that's a cool shortcut. Okay, now I've got to state the domain and the range of each of these values. So I need to start thinking about, what does a cos squared graph look like? So have I considered everything here? I've got x of t is equal to 2 cos squared of t. And I know that t is an element of R. So the x values, don't forget, become the domain. So if we look at the same thing before, this becomes the domain. All of the outcomes to this expression for t, all elements of R, or the range of this expression, becomes the domain of the Cartesian equation. So let's have a quick think about what 2 cos squared t looks like. So if it's a cos squared graph, now if it was 2 cos t, we saw that before, 2 cos t looks like this, up to 2, down to negative 2. Now if we square all of those values as we go along, what ends up happening is when I square a negative, it becomes a positive. So my graph becomes all of these positive values. So my range of this expression, which becomes the domain of the Cartesian equation, is from 0 up until 2. Okay, so there's the x values which form the domain. Let's have a look at our y values. So y was 3 sine squared t. And again, we're going to have a look at the graph here. So if I think of the graph of 3 sine squared, so 3 sine squared normally looks like this. Oh, sorry, that's without the squared. When I square it, all of my negative values become positive values. So all of the negative values become positive values. And I end up with this sine graph. And so the range or the outcomes from this graph for all t ends up being from 0 up until 3. And the outcomes of this graph form the range of my Cartesian equation. So the range of my Cartesian equation is from 0 to 3. So I drew this nice graph up here before, but I've actually got too much information. I don't want to have the entire graph. My graph has to have a domain from 0 to 2, and it has to have a range from 0 to 3. So that's my entire Cartesian relationship. And I can actually state, I can go a little bit further, and I can say my Cartesian relationship is y on 3 plus x on 2 equals 1, where x is an element of 0 to 2. So I've stated the domain in there. Okay, how is that possible? Well, because these graphs are representing particles travelling in space, what would happen with my particle is it would start somewhere on this line and it would travel left, for example, so it might move this way, and then it will hit this maximum point and then start going back the other direction, hit this point, then move back the other direction. So it's like a little rebounding ball that keeps moving backwards and forwards along the same path for t equal to r. Okay, that's the end of this video.